Hello everyone, I am Selvi, Assistant Professor, CSE Department, RMD Engineering College. Subject code is 22CS201 Data Structure, Theory course with Laboratory Component, Academic year 2022 to 23, Second Semester, Unit 1. Now we are going to see about deletion in singly linked list. So before going for the deletion operation, first we have to know what is meant by singly linked list. So linked list will come under the category of linear data structure. So singly linked, so the types of linked list is singly linked list, doubly linked list, circular linked list. So even in circular, you can implement both in singly linked list circular manner and a circular doubly linked list. So what is mean by singly linked list? Each node, so each item in a list will be considered as a node. So each node follow the structure of data part and the node to the and link to the next node in the list. So if you consider this is an example of a single linked list. So 45 is the data part. So 45, 98, 3, all the data parts in a single linked list, and 2000, 3000 and null will be the memory allocation. That means a linking to the next node in the list. So initially the first node will be the head. So creation of the head node, the memory allocation will be 1000. So next node is 2000. So I'm connecting the 1000 node and 2000 node by giving the connection like head next is equal to for example, the node name for 2000 is current, head next is equal to current. So like with this, I will be connecting each node parallelly. So this is the structure of a node in singly linked list. Now we are going to see deletion in a singly linked list. So deletion can be done at the beginning, at the end, and at the specified position. So now we are going to see deletion at the beginning. So first I am creating the node structure. I'm calling the function. So this is the structure of my list. So here I have 3 nodes. So for pointer will be pointing to the first node. Now I'm going to delete the first node. That means the head 45 data 45 should be deleted and this block should be deleted and my pointer moves to 98. So this is my work. So what I will do is I will call the delete first function passing the parameter of head. That means the first node head memory allocation pointer will be passed and the return value will be return list will be saved in head, which is again assigned to pointer variable. So next PTR, that means PTR variable. So until the PTR is not equal to null, because the last node in the linked list will be, the next pointer for the last node in the linked list will be null. So until I'm reaching the last node, I will be printing each data and pointer equal to pointer link will be pointing to the next link. So delete first. I'm passing the head. That means the entire list, the head node at first. Head, if head equal to null. If head equal to null, that means if there is no node in a list, that if it is empty node, then we'll print the message as list is already empty. Otherwise, we will be go for the else part. Here I'm creating a temporary variable, which is again pointing to head. So head and temp both will be pointing to the first node. Next, head is equal to head link. So head link will be 2000. Now the head position will be pointed to 2000. See here, from 1000, the head pointer moves to 2000. And next I'm freeing the temporary. So using the temporary pointer variable, I'm freeing this memory. So 45 will be deleted. I'm freeing now, I'm freeing this memory. So in temporary, this 1000 will be considered as a garbage value. So even I'm deleting that value by assigning as null. Next is deletion at end. Like deletion at first, deletion at end also, the head parameter, head of the list will be passed as a parameter. If head is null, that is no item in the list. Otherwise, if head is not equal, head link is equal to null. Head link, that means the list have only one node. One node in the entire list, we will be clearing the head node. That means the single node in the list will be cleared. So this else if part is applicable if there is only one node in the single linked list. Then we go for the else part. So here if we have multiple nodes in the list, so here we have 3 nodes, we are going to delete node number 3. That is data part is 3. Memory allocation part is 3000. I am declaring 2 temporary variables, temp2, both is assigning to the head. So head 1000 value, all the three variables will holding the value 1000 memory allocation. Next is while temp link not equal to null. So temporary link, which is that is 1000. 1000 link is 2000. Is not equal to null is true. We go now temporary 2 is equal to temp. That is temporary 2. Now move to the next point. What we are doing in the first line of this code is we are moving the temporary 2, temp2 pointer value from the head to the next one. And assigning and again using this, we moving the temp pointer, temp equal to temp link. Using this, we are moving to the next node. Likewise, we will be moving to the last node. So can you able to see using temp equal to temp link, we are moving to the from the head node moving to the next node. So now temporary 2 and temporary both pointed to temp. Likewise, again the next temp link is not equal to null because now the value is 3000. So again, it will be moving to the last node. So it will reach the last node. So it will reach the last node when temporary 2 is null. Link is null, we will be freeing that. So now temporary 2 link is null, we will be freeing the memory. And returning the entire list to the main function. Next is deletion at specific position. Here the head pointer to the pointer variable head, that is the entire list and the position. Now I am assigning a temporary variables current and previous, both will be pointing to head. Here I am passing as the parameter. Here I am passing the parameter. Here you can see double asterisk, that is pointer to a pointer variable. So head location is 600. That memory location 1000, which is again pointed here. Now current and previous all pointing head, current, previous all pointing to the first location 1000. Now the position value I have considered is 2. That means position at 98. Data value is 98. I want to delete this 98 node. and I have to give the connection to the from the 2000 to 3000. I mean from 1000 to 3000 without passing 2000. This is my work. First, I will check whether the list is empty by checking the head value. Next, if position equal to 1. If there is only one node in the list, head is equal to current link. So I will be deleting the first node. Otherwise, if position is not equal to 1, what I will do is previous equal to current. So previous equal to current. What is the current value? 1000. So where's the 1000 pointing to 2000? So previous will point to 2000. And current will point to, current link will again point to the 2000, and position value is decremented. And what we will be doing is, will be freeing this memory. Current will be freed and pointing to the, and moving the pointer previous link, that is previous link 1000 will be pointed to 3000. This is how the connection will come. Thank you.